Alright everybody, this is network attached shell, N.A.S.ty systems that store network accessible shells. Some of you may have looked at the program and seen Jacob Holcomb talk at other events. I am not Jacob Holcomb. We tossed a coin, he went to Amsterdam, I came here. I'm presenting this research that was conducted by Jacob Holcomb at Independent Security Evaluators. I'm a software developer, I'm a co-worker with him. This is his information if you want to go bug him on Twitter or LinkedIn or check out his blog. Feel free to do that. He's having a good time right now, so I encourage everybody to give him a hard time. A little bit about ISE. We're ethical hackers and computer scientists. We've got customers in Fortune 500 enterprises, in the entertainment industry, healthcare. We like to look at systems, white box if we can do it. Why make it hard for ourselves? So why are these sorts of, why is it important to check out network attached storage systems? We bought 10 network attached storage devices, and we found that 100% of them were vulnerable to exploitation. We have no reason to assume that anybody else's are any better. Storage systems are not the only embedded devices with software deficiencies. Some of you may be aware of ISE's other research, these small office, home office routers, which are also fairly Swiss cheesy. And as we add more and more things to our lives, this is just going to become more important. Now include everything up to your thermostat is now networked. So we're going to go over some of the key players. What are network attached storage devices? What are some of the system functionality? We're going to talk about exploit research and development and the absence of security on these devices. And then we're going to talk a little bit about how we can remediate it to the level that we can. Some of the key players: Seagate, Western Digital, Netgear. You know, your usual suspects for small office, home office equipment. If they make a router these days, they sort of make. Most of them also make some form of network attached storage, and everybody buys these. A homeowner might, like a home user might buy one to store all their digital pictures or their music files. Small businesses, it's a great way to have a bunch of network attached storage without a whole lot of administrative overhead. And large enterprises, these sorts of things also show up in large enterprises as well. Everything from blessed installations where the IT department allows them to install this, or a small department decides they need some storage and they don't want to go through IT, so they buy it and just connect it up. This is a list of the devices that we were evaluating. Tried to get a big cross-section of the market as it stands. Some of the technology that's implemented on these network attached storage devices. I mean, obviously, network attached storage, you have to have the ability to store and retrieve files. So you've got Samba and NFS. You've got to configure it. So you'll have Telnet, SSH, HTTP. And then there are some things that we find unnecessary. Why would you want to go to the cloud to manage the device that's sitting right next to your computer? I haven't quite figured that out, but apparently the cloud sells these days. So we're going to go through. We've got a summary of results. We're going to talk a little bit about how we tested it, and talk about exploitation and a couple of demos at the end of the talk. As I said before, every device that we tested had some form of root compromise. Half the devices could be exploited without authentication. We've got 22 CVE numbers assigned by MITRE, and we've only just started. These things are chock full of holes. So, scanning and enumeration. We just did, started off with the basic system scans. We nmapped all the devices, checked what open ports there were. We grabbed all the banners, and we used that to guide our future exploitation. All the running services we examined. We got a hold of the source code for web applications, places where they use GPL software. This is available online. We analyzed the web applications for common vulnerabilities, and we did some network fuzzing. We discovered cross-site request forgeries, buffer overflows, we've backdoors, poor session management. Basically, the laundry list of all the things that you find that could be problems, somebody has as a problem. So when we managed to get into the Seagate, we poked around a little bit, and we did not use the backdoor, but we discovered, as you can see, there's user W4L980CK blah 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 with a password. So Seagate has helpfully left us an account with a password on our devices. Thanks, Seagate. Moving on to the ASUS store, we analyzed their, in this case we're showing that we're analyzing the session cookies. To the left of the screen, you can see the cookies in a list from several connections. Note the 53DF-C90. The cookies showed a very low amount of entropy, meaning they're easily guessable. The entropy basically all exists in the last 2 bits. So poking around a little bit more, we decided to just print out the time of day in seconds, and note the 53DF prefix again. It sure looks like instead of generating a random session cookie, they just grabbed the time and used that. So then we move on to exploiting the vulnerabilities that we discovered, exploiting things like command injection. There are missing function level access controls that we found, and the whole gamut. Command injection is where the user input gets eventually used by something that runs a system command. Many of the management interfaces are borrowed, so the web application behind the scenes is calling a Unix system command to execute something like turn on Samba. And unfortunately, they don't do a good job of scrubbing user input, so if you add to the end of that, we can run other more nefarious things. Developers, please try and implement countermeasures. We do not want, wherever possible, avoid calling shell. That's just asking for trouble. If an API doesn't exist, gotta sanitize the user input. The user is going to put in something that you don't like, or if not the user, then somebody like us. We need to just make sure that we do a good job of wiping the input so that things like reverse shells don't make through. Sorry, my slides got out of order. Cross-site request forgeries. I think we are all familiar with them. It's an attack where we convince an unsuspecting victim to execute a web command, visit a website, and that website uses their credentials on their browser to go do something at a third site. There are ways that we can avoid the problems associated with cross-site request forgery. Log out of all your web applications. There's no reason to leave yourself logged into your router or your network attached storage. Don't save credentials in your browsers. Manufacturers, we need to implement anti-CSRF tokens and check to make sure that you're coming from a location that you expect, not, we don't want to be running administrative commands when our refer is not the administrative interface. If we're coming from someplace in Czechoslovakia and we're in the United States, that's probably a bad thing. Other things, anytime you change a state, change a password, turn on or off a service, it would be a good thing to force the user to re-authenticate to the system. Missing function level access controls. It doesn't do much good to put up a big security door when somebody can just walk around your nice gate. When you're actually performing the important task, changing a password, turning on external web access, make sure that the user that is performing that action is both authentic and authorized to perform that action. Buffer overflows. We've been working on these since 1993. They're still here. You have 128 bytes, and the user gives you 512, and now you've overwritten everything else on your stack, and bad things happen. We know the problem. Quit using unsafe functions. Don't use strcpy. Don't use sprintf. Perform bounds checking. Make sure that the input that you expect to be 128 bytes actually is no larger than 128 bytes. Let the compiler help you out. We've got stack protectors. We've got data execution prevention. Please turn these on. These are not on by default in the devices that we evaluated. There is a worm that Jacob Holcomb has been working on. He is going to be giving a demo at, he's got a webinar that is scheduled for October 23rd, I believe. If you visit his website at the beginning of this, he has when and where pre-registration is required. His worm currently operates on the following devices. There are other worms that have happened in the wild that are similar. The moonworm, and there was a worm that at QNAP uses shell shock. That was recent. The worm scans for an open network attached storage device of the brands listed, fingerprints to make sure that the device is what it expects, exploits it, downloads the worm, keeps going. So your typical worm operation. These things, this will be demonstrated in the webinar. There's the webinar's address. Like I said, October 23rd. So we're going to look at the TerraStation 5600. We've got command injections, and we've got missing authorization checks in this demo. Here we're logging in as the administrative user on the interface. Note the session ID. We log out, and then we come back as the guest user, which is a non-disableable account on this device. It always exists. Note we are now logged in as guest, not as admin. Here we're showing we're trying to connect to the device. Nothing is running on it. We've got a new session ID. So note this session ID is not the session ID of the previous admin. Here we're showing a request that does a edit of the password. We're replaying the request from the admin. Note invalid session ID. So the old session ID for your admin does not work. We grab the session ID for the guest user and we replace that. And we get a response. The password change on this particular device is a two-step process. So the first step is it's expected for that to be null. Here we go through and we're operating the second step, changing the session ID again to the guest user's session ID. And we see that the device has changed the password. Here we're going to log in now as the administrator using the newly changed credentials. That's the password we're using up there. Copy and paste. Log in. So guest has successfully changed admin's password. Now we see we've got a new session ID, and we're going to use command injection to start up a telnet server. Telnet in and root. Congratulations. The next thing that we're going to look at is Netgear Ready N.A.S. 104. That's this device sitting at my feet. This one we're going to use a command injection and a cross-site request forgery. This does require tricking an unsuspecting user to visit a page for the cross-site request forgery to work. Over here, I am logged into the Netgear Ready N.A.S. I'm logged in as admin. Some form of phishing attempt would be needed or you'd have to convince them to log in, but then we're going to right here we're starting up a netcat session. It's listening on a port. We're going to start up a reverse shell. Up here, we have an example web page that you would have to trick an unsuspecting user to. There is let's see if I can see where it is. So right up there, the busy box, NC, is where we've got a reverse shell that we're going to have that we're going to inject into the system, and that will connect down, and we'll be able to see in the lower terminal a connection. So over here, we're going to visit a website which unfortunately is cut off a little bit. Let me see if I can rearrange this a little. So this is the file that we catted over here. So we're going to convince our user to visit this website that has the cross-site request forgery in it. And it's sitting here. Now we come down here, and we've got a root shell. We can do things like browse around on the system. You can see we've got the shadow password file. We can even do fun things like add user. And now we happen to have, now if we check shadow, you can see we now have added an additional user, and he has a home directory and everything. So that's fun. These systems really don't have much in the way of security as they come out of the box. This is not just network attached storage systems. Layer 3 routers, the ISE Soho office, the small office, home office router project has already shown routers. We've got IP cameras that are beginning to show up. Thermostats are, the N.A.S.ty, various other companies are manufacturing devices that are intended to bring about the Internet of Things, but these things really don't have a whole lot of security, and nobody is really focused on making these devices survive the hostile environment they're going to be in. The router project has over 56 CVE numbers. We have more than 20 CVE numbers issued for problems in network attached storage. We will continue to keep exploiting these things and submitting to manufacturers so that they can harden their devices, but right now don't trust them out of the box. So what can we do better? Vendors, a lot of this for the average user is going to rely on vendors. Patch management needs to be a larger part of their system. We need to be able to fix these holes as we find them. We need to work on developing these devices secure out of the box. Implement things like defense in depth. If we don't want a file we don't want a router that can then lead to a compromise of our file server. Least privilege. Don't let a user that is just storing files on the device. Don't let them change IP addresses. Consumers, when you buy one of these, there are a few things that we can do to help reduce the attack surface. Change the default credentials when they come from the store, and the admin account is admin and the password is admin. That lets anybody who drives by load up and get into your device. So try to disable services that you don't need. If you don't want to manage your network attached storage through the cloud, make sure to turn that off. Just in general, try to avoid leaving these things in the state as they come out of the box. Upstairs we have been running the So Hopelessly Broken hacker contest. Sorry, we've been running this at DEF CON and DerbyCon. We'll see you again at TourCon. You can talk to us about our previous research with the small office and home office routers and so I guess I'll open the floor to questions. If there are some, I apologize. I'm not Jacob Hall. Yes, they are. Some of the vendors have been more responsive. If I was Jake, I could probably tell you which vendors have been more responsive. We have been following responsible disclosure. We've been telling these manufacturers about the problems, so hopefully they have or will have firmware updates in the near future. It's not quite as good as home routers at this point, where you can just download something like DDWRT. But hopefully we'll get something like that for the network attached storage. So the question was, have any of these vulnerabilities been found in DDWRT and OpenWRT? I actually don't know. I would suggest pinging Jacob Holcomb on one of his forms of contact. He would be able to answer that. So the question is, what can we as the security community do to help this situation? Name and shame, create competing products. At the risk of putting my foot in it, I'd say probably a little of all of the above. I personally favor responsible disclosure first. Let the manufacturers have the opportunity to fix their problems before we go about pointing fingers. I think pointing fingers should be reserved for only very egregious cases. Creating secure products. I mean, the market will tell, I suppose. I mean, DDWRT and OpenWRT came about because small office and home office router firmware was not sufficiently powerful and not sufficiently secure. So I see no reason why a project such as that could not be started. I think it would be good for the market as a whole, but that's something that can be done. Anyone else? The question was, have we looked at network-enabled printers and scanners and whatnot? Not yet. I think it's on our plan of things to do, but I don't want to talk for other people in my organization. These seemed interesting, so we started looking at them first. Anyone else? see any more hands, so I guess thank you for your time.